Welcome to part 9 of our Link G4x mini training series here. In this tutorial, we're going to be exploring setting up our output programming. So we're going to find how to program an on-off type of output or a pulse width modulated output. Without further wait, let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at setting up our output control using our Link G4x systems in our mini training tutorial. We're going to take a look at setting up two different types of output control. We have an on-off control and we have pulse width modulated abilities with our outputs using our G4x. We're going to take a first look at setting up a VTEC output to control a VTEC function on a Honda engine, and then we'll look at setting up a pulse width modulated output for boost control. And we'll talk about the differences as we're setting these up. Let's jump in here and take a look at how we're going to first work with setting up a VTEC function as a basic on-off control. We're going to move from our fuel tuning page here, and let's go over into our open window here. Let's create a new page layout, and we're going to call this outputs. Okay, and then we're going to jump in here to our ECU settings, allowing us to access the window where we're going to go and set up a general purpose output for our VTEC function to work properly here with my Extreme box that I've wired into my vehicle. So we're going to move into our aux outputs option here into our drop down menu, and what we'll find here is that we have some pre-configured outputs that we can just select to work with if we want to go in and program some of these functionalities. So we have our engine fan control, fuel pump control. Those are probably the two very basic most common outputs that we have to go in and work with, because we either need the fan to turn on to cool the engine down or the fuel pump to turn on so we build fuel pressure and we can fire up our engine. We do have other options here. Again, anything with a wrench icon, that's going to allow us to set up this particular output. In this case, we don't find a wrench icon that's set up for a VTEC function. So what we're going to have to do here is use a general purpose output, which we can find right here, and we can select either an output, which is an on-off control, or pulse width modulated, which is going to send us a pulsed type of output control. So two different types based on the circuit you're trying to work with. In this case, we're dealing with VTEC, which is just going to be on or off, and it's going to be specifically sending a 12 volt out from the link to control that VTEC solenoid. So we have to go and configure our basic output control here in the on-off fashion so that it is going to control that solenoid properly. Let's jump in and take a look at setting up a general purpose output. So we'll use our general purpose output 1 here, double click, and that's going to bring us onto the screen. We're going to move this over here into the corner, and we're going to go ahead and lock it in place. And then we're going to go up here into label, double click, and we're going to call this VTEC. So we have this function defined. And then we're going to go to our output, and this is where we've assigned the actual output pin to control this circuit. Now on a Honda VTEC engine, we'll find we have a VTEC solenoid. The VTEC solenoid's job is to allow oil to pass through the solenoid to go into the cylinder head to lock the rocker arms, so the secondary profile that's on the cam can be used, and essentially we're actuating the valves opening and close based on that higher lift and duration profile. It's all based on oil pressure, which is based on the VTEC solenoid, allowing the oil pressure to flow into the rocker arm assemblies and lock the pin in place so the VTEC function works. What we need to do here is make sure we're setting our output to where we've wired our VTEC solenoid. So double click here. In my case, I've wired it here to my aux 5. Let's go ahead and click OK here. Now we need to give this a second. It's going to pop up here with a bunch more options we have to program. Now under our aux options here, we have our aux 5 test, aux 5 active state, aux 5 driver type. Now let's talk about here for a basic on-off control. We want to turn our device on or off. That idea is pretty straightforward. So cooling fan, we want to turn it on and off based on coolant temperature. The conditions that we find down here, what we're going to program to turn our function on this output pin on or off. But we need to consider, in this case, the state that we're sending out to the VTEC solenoid. So the VTEC solenoid is going to be activated with a high side output or a 12 volt output. There's one wire on a VTEC solenoid, and that specific wire gets a 12 volt output. The solenoid itself gets grounded to complete the circuit against the cylinder head. So what we're going to find is that we need to configure our active state and driver type so that it's going to be sending a 12 volt out. How do we do that? First thing under driver type here, we're going to assume that we're sending a high side output that's sending a 12 volt output. Now you might be sending a ground output through your pin if you're controlling a relay or a device that needs a ground output, which would be low side as your option for the driver type. But in this case, we want to choose high side. We're going to click OK. Now the active state here, we can either send it out low or high. Low means that we're going to be grounding. High means that we're going to send a 12 volt out. So we went high and high as our two options. So high side on the driver active state is high. We do have a test function that might be useful to test to make sure this output is going to work properly and the circuit you're trying to control is going to work properly before you actually start to run the engine and start to use the function. So off means that the function is off. On means that it's just going to latch on and stay on for as long as you have this set to this option here as test is on. And then on PWM means you'll send out the signal in a pulse width modulated format. We're going to talk about that here in a few minutes for output control. We're not interested in testing this in a pulse width modulated type of functionality. We're interested in testing this in the on or off state. So you can go here and you can test this to see if the device is wired properly and it's working. So it's just a nice test functionality they have in the software here. Well, let's just click this as off and click OK. So now we've assigned the output as a 12 volt output to control our VTEC solenoid. The next things we need to consider are going to be our logic programming. When we want an on-off type of functionality here to turn on and turn off. So in this case, under our switch logic, I actually like to go ahead and use a couple things for programming here. There's a condition 1 only, which looks at just one parameter or condition for the output to turn on or off. There's also condition 1 and 2, or condition 1 and 2 and 3. If we have our conditions 1 and 2, it means need both conditions in order for the output to turn on. 1, 2, and 3 means it has to meet all 3 conditions for it to turn on. Then we have some other functionality here. There's an or. It can meet one condition or the other as we're programming here for parameters. And then the list goes on and on here. I'm going to choose 1, 2, and 3 for my VTEC function to work properly here. And then what we're going to do is program our parameters here. So we need to consider a couple different things for VTEC to turn on. One, we want it based on engine speed. So we'll have our parameter 1 here, engine speed. Parameter 2 here, we can do it based on throttle position. So we want to be above a certain amount of throttle position for it to engage. And then lastly here under parameter 3, we want it based on something like our map pressure. Map pressure is going to be a logical type of programming option for the VTEC function to turn on, because we don't want it to turn on if we're at lower load conditions where the map pressure is going to see a lot more vacuum. We want it turning on at higher load conditions where we have little vacuum. So I'm going to type in here map as my option. It should pull my parameter list up here as my map. We'll give it a second here to go through the filtering, and we'll grab map as the input here for the parameter. So there's an on and off delay. This would be how long we're going to wait to turn it on after it meets the conditions, how long we're going to turn it off after we've dropped below these conditions. So the way this is configured right now in the switch logic, we have to meet all 3 conditions. We have to be above all 3 conditions. In order for it to turn off, it has to drop below all 3 of these conditions. I'm not going to wait any time here, so I'm going to use 0 and 0 as my on and off delay. So if it meets the conditions, it immediately turns on. If it doesn't meet the conditions, it immediately turns off. That's how I want the VTEC function to work here. The conditions here, they're going to have these symbols, conditions 1, 2, and 3. And we're going to go in here to our conditions, and either we have less than, greater than, equal to, or less than, equal to, greater than, equal to. We see there are different options here. What I'm going to say here for engine speed is that we have to be greater than, and then we have to figure out where that specific engine speed is going to need to be for the VTEC function to work. Let's assume that we test and we find that 4,000 RPM is going to be ideal for VTEC to turn on, so that's fine. Parameter 2 here, this is throttle position. This is saying that we have to meet our condition here of whatever we've programmed for the throttle position movement. So in this case, we have our less than, greater than, equal to, or greater than, less than, equal to options here. In this case, I'm going to say is going to be greater than, and I'll say 50% throttle for it to engage. I don't want to engaging when I'm part throttle, make the car not drive smooth, and our fuel economy will go down. The last parameter here under map, we're going to say when you're at least 80 kPa of manifold pressure for it to engage, and we're going to use our condition here as greater than. So we have to be greater than 80 kPa, greater than 50% throttle, and greater than 4,000 RPM, and the VTEC function will turn on. So we can see how to set up a general purpose output for a basic on-off control. Hopefully that makes sense here. Let's do a store and store all of this to our ECU and to the link for the VTEC function to work properly. Now the next example of setting up and working with an output control would be for a pulse width modulated circuit. So things are a little bit different in a pulse width modulated type of functionality. We can set up a general purpose output for a pulse width modulated type of control, but usually we're not going to go after a general purpose here. So remember here under general purpose, we have pulse width modulated or we have outputs. Outputs are for on-off control. Pulse width modulated would be for a pulse type of control. So I'm going to go ahead and just show a very commonly found pulse width modulated type of output that we're likely to be working with, and that's going to go under our boost tab here under our boost setup. We're going to go ahead and take a look, talk about here real quick. We'll just set this to open loop, and it's going to have my drop down start to populate here in a second. This is going to allow me to, let's just click yes here. It's going to allow me to do some programming here. It's going to allow us to set up our output control. And this is going to be what specific pin we're assigning to control the boost control solenoid. Now on a boost control solenoid, 2 wires, 1 wire goes to power, the other wire goes into our link. And in this case, we would assign it for whatever output here we've wired it into. I've assigned my boost control solenoid here to my aux6, so I'll click OK. And then we have our frequency here we need to go and consider. We also have our state to consider. So we see we have a bunch of different options here. Let me actually go ahead, just open this window up here so we can see this a little bit easier. So in the test function, just as we found in our on-off control, the test function allows us to either test it in either being an on status or an off status, so energizing the circuit, not energizing the circuit. Because it's pulse width modulated, we'll be wanting to use on PWM to test the circuit to make sure the solenoid actually clicks and buzzes before we start to work with it. That just allows us to ensure that that circuit has been wired properly and the device we're controlling, in this case, a boost control solenoid, does work. So we do have that option here to test the output. Activation state. This is where we need to consider if we're sending a low side output or a high side output. When we're dealing with a boost control solenoid, if we've wired one wire, there's no polarity on the wires, but one wire is going to a 12 volt source, the other wire would then be pulse width modulated, grounded. So we're going to be ground pulsing the other wire to energize that solenoid. And the activation state here would be low in that case. Now, if you've inverted the way you've wired it, let's say you've grounded the solenoid to chassis ground, and then you've taken the other wire and you've ran it into the link, then we would be sending a 12 volt pulse out to the solenoid and actually pulsing 12 volt as we're trying to control the boost control solenoid. So it depends on how you've wired it. Traditionally speaking, we'll be sending a low side output to control boost control solenoid, and we'll be running one of the wires to a power source. So make sure you're selecting it correctly. Now the frequency here is something different from what we found in the on-off control. The frequency is how many pulses are going to occur in a second time interval. So 10 hertz is 10 pulses in a second. Now it just so happens that the boost control solenoids, you'll find that most common on the aftermarket are a MAC boost control solenoid. MAC valves are supposed to be pulsed at 31 hertz, so 31 times in a second. It's important that we get the frequency correct for a pulse width modulated device and circuit, because if we have the incorrect frequency, we won't be controlling things properly when we're trying to work with the output functionality. And we do have a couple other additional things here for working in the boost control. So where we want the RPM to activate at, the map pressure that we want the control solenoid to turn on at, deactivation timeout, so once we drop below our thresholds here, how long until the solenoid turns off, 0 seconds is fine. And then there are other programming details found within the boost control routine, which we're not going to cover here. So programming any type of pulse width modulated control, we're gonna have to consider our output state, if we're controlling and pulsing in a ground type of pulse or a 12 volt type of pulse to control that circuit. Again, depends how your circuit is wired. And then we need to consider what the frequency is going to be. That's how many times in a second we're going to pulse that specific circuit. So this is, again, very specific, and you'll have to know that information as you're programming. But that's going to wrap it up here, taking a look at setting up and programming 2 of our basic output type of control. Now this is just getting a very small taste of the programming capability with our Link G4x system. We have over 100-hour training course available on evansperformanceacademy.com, where we take a look at programming, getting in more depth with the output control. So if you're looking for more information or you want more in-depth tutorials, we have those to offer with our G4x course, where you can subscribe monthly or you can purchase the course outright. So definitely check that out. That's going to wrap it up here. I'll see you guys now in our next mini training tutorial.